Hello everyone, my name is Sagi Kratu, and in today's session,
We will discuss the security challenges of Kubernetes clusters and how we manage the container-based applications around them. Let's begin with a bit of a primer around this to ensure we're all on the same page around Kubernetes. Why do we use Kubernetes? What is the value we get from them? And what are some of those challenges that are caused as well? Then we'll talk about the security challenges around Kubernetes. Why is it so difficult for security teams to understand what's out there and what you can do to secure them? Then I will share what we're doing here at Orca around security and visibility into these clusters, specifically around context, prioritization, and compliance. I will share with you some customer stories and use cases as we go along, since their experiences are indicative of the things that we see across the industry about the struggles that different teams have. It helps to illustrate the different ways you'll secure Kubernetes clusters and the value a good security tool can bring. The first thing to talk about when discussing Kubernetes is Docker. A long time ago, which is only about 10 years ago, Docker came about and started packaging applications together into a unit of virtualization called a container. You build a container image, and then you can deploy that container one or many times across your environment. This actually revolutionized how we write, deploy, and develop our applications, but also how we secure those applications. Docker promised many things, from cost-effective and fast deployment, and the ability to run your code anywhere, build it locally, and have that same environment when you deploy and redeploy into production, enabling the modern microservices architecture. When you hear about developers decoupling and distributing their applications, they're almost always doing this with something like Docker and containerization. There are many benefits to containerization. During this process, some struggles come along. And the main thing is that it completely disrupted our norms, the way we run our daily business, and our security. Because things are built and deployed rapidly, it becomes difficult to understand what is running in your environment, who owns the items in your environment, and who needs to resolve them if issues occur. It also made it challenging to scale security operations or enable new ways of scaling operations. Because of the way that microservices work and containerization is done, it made it extremely easy for an application to go from maybe one container running on a regular business day to Black Friday with 100 containers running and then back down to a few the very next day. That's excellent for your operations team, but it can be an absolute nightmare for security teams who were used to remoting into machines and patching them and updating them to resolve vulnerabilities, who now need to come up with an entirely new way to understand what was deployed in the environment. Even more so, infrastructure and networking teams had to cope with this challenge as well. So the question that organizations came to is, how can we deploy? How can we orchestrate these containers in a reliable production-grade environment? That's where Kubernetes came in. It was invented by Google in 2014, and the goal was to bring container orchestration to the masses with an open source solution, automating deployment and management and scaling, and do all of that and make sure that the Docker containers that are running in your environment are running on the VMs that you would expect them to be running in with the configuration you want, with the networking around them. Over time, Kubernetes integrated tightly with cloud providers, so that when you configured a container to be exposed to the internet, it would make cloud API calls that spun up load balancers and configured rules to ensure all were routed correctly. This accelerated cloud adoption has let us deploy our code faster, reducing the cost of developing applications. But why talk about this now? Why is this important 8 years after Kubernetes was launched? The pandemic has been the catalyst that caused many companies to kickstart their migration to the cloud. Maybe they had dabbled a little bit with Kubernetes. Perhaps some developers or some of their innovation teams have played with it. But now Kubernetes has taken over how we run our main business applications. It underlies the foundation of many of the largest corporations running in the cloud today. The benefits are fantastic, but the struggles are real. Before we go forward, one important thing to cover is a little bit about how Kubernetes works under the hood, which is essential to understand when discussing securing clusters. Ultimately, Kubernetes is just a way to ensure the proper containers are running on the right hosts and the correct number of containers with the appropriate configuration. So your Kubernetes cluster, whether you spin it up yourself, manage the control plane, or let a cloud service provider like Amazon spin up an EKS cluster or Google spin up a GKE cluster, ultimately you have virtual machines in your cloud account with containers running on them. In AWS, they're just regular EC2 instances, but one's managed and controlled by the cluster, so they can scale up and scale out. In most cases, you have a Docker engine on each. So you're still running containers and running them on different Docker VMs in your environment. And Kubernetes is going to control if you have one container running on every node in that specific cluster. Maybe you're stacking them on the same node. Perhaps there are certain affinities that they need so that the same containers run in the same places for specific reasons. But ultimately, these are VMs under the hood, and they are backed by the same block storage your typical workloads run. You can remote into them, but generally you don't need to because you interact with them through the Kubernetes API or the kubectl command. Both have a lot of extra metadata you need to understand and add the context that your developers are seeing. So if you look at it from an infrastructure perspective, you're missing half the story. You're missing the fact that Kubernetes has all sorts of metadata, like the namespace, like the service, the deployment, the persistent volume. Those are the things that your developers will know very deeply because it's how they built their applications. But it's typically not exposed to security teams unless they're Kubernetes experts. This leads us right into the customer challenges that we've seen. The first one is about a rapid growth FinTech company that we work closely with. They have a multi-cloud architecture and are deployed across the 3 leading cloud providers. The customer has different cloud admins or different teams managing each of those clouds. In general, they're using infrastructure as code to deploy their clusters. They were using Terraform and CloudFormation to ensure those clusters were provisioned and deployed out in that environment. Some of the challenges that they were seeing and why they were looking for a new security tool is because they were seeing a high turnover rate. The DevOps team that wrote and deployed their Kubernetes clusters and were going to maintain them have left the company. Now security is tasked with securing these clusters deployed in their environment that they didn't write or develop. And honestly, they're not experts in Kubernetes to begin with, but Kubernetes is the backbone running their production application. So they needed the ability to see those clusters and communicate with their developers. As part of that, they decided that they would do a combined DevSecOps team, and this team was the one working with us. They explained a couple of key challenges that I'm going to share. The first being misconfigurations. While the default Kubernetes configuration options are acceptable for quickly spinning things up, they are not necessarily designed with security in mind. So you still need to go in and make sure you're hardening the nodes and making sure they are production grade and secure. Also, they struggled with a lack of visibility, even though the clusters were deployed in their environment. And even though they could see the infrastructure in their cloud accounts, they did not have a good tool to provide visibility of what pods were running in that cluster, what Docker containers were running under the hood, what vulnerabilities or malware or exposed keys or compliance issues were inside those containers. There was also the challenge with mitigation. In the past, the security team had remoted into machines to patch them when issues arose. For example, Log4j, the admins would go into their traditional security tools deployed as an agent across most of the environment and patch whatever is needed. Patching containers is an anti-pattern. You cannot patch running containers because Kubernetes will spin up a new container from the immutable Docker image that is unpatched the next time that the container goes south or an EC2 instance is reclaimed or a cluster scales out. So the only way to patch is to go in and rebuild the Docker image and then update your deployment in Kubernetes to have a new version, the new patched version. Now this is a complete paradigm shift for the security teams because they could no longer patch the host and call it a day. Instead, they had to work closely with the DevOps team to route discovered vulnerabilities back to those teams. And then there was the issue with the broad attack surface. If a container is breached, if a Kubernetes node is breached, the attack surface is directly related to how broadly you can communicate with other containers and pods. Part of the best practice they wanted to enable was ensuring developers were isolating containers correctly, their namespaces, their pods, etc. With the distributed nature of these containerized applications, enabling policies is hard. Still, it's much more complicated to investigate which container might have vulnerabilities, where they reside, and what the rules around them are. What type of misconfigurations are there? and then prioritize and highlight the most significant risk to the organization. Some of the questions that must be answered to address the security postures are: what is running in the environment? Are there unapproved images out there? What registries do the images come from? Are our developers using approved images? Are they using items scanned and gone through your CI/CD pipeline? Let us say that a compromised Kubernetes cluster was spinning up containers with crypto miners inside. Would the sec admin be able to see, detect, or know that that was happening in their environment? Without the tools built with Kubernetes awareness in mind, you have to go in and get a security professional who is a bona fide Kubernetes expert who genuinely knows how Kubernetes work and how to write and deploy them. And honestly, those people usually work in writing and deploying the applications and are not necessarily on the security side of the house. So they needed a tool that provided a lot of that expertise built in. A second company had primarily the same challenges, but from a much different perspective. A global media conglomerate that we work with, and their environment is a mixture of self-managed Kubernetes and cloud-managed Kubernetes that was primarily grown through acquisition. Acquisitions are challenging in cloud-native deployments because many teams still rely on those legacy agents that need to be deployed everywhere. When you inherit a cloud account that may be 5 or 10 years old with things deployed in it that have aged that no one knows why they're there or what they're doing, it isn't easy to get it integrated into your security tools. And now, surprise, you have 2 security tools. So during the pandemic, this company migrated all of its self-managed clusters to EKS, AKS, GKE to streamline and standardize the environment. Security was part of this effort. They wanted to do this to reduce the workload on the team, reduce the different things that needed to be learned and maintained, and also improve the time to deploy and integrate new applications. So the security team had no control over applying these configurations, but they could define best practices on how the cloud infrastructure should look and what parameters each asset needs to have. They needed a tool to support them and ensure that the policies and requirements they enacted for running Kubernetes were being followed, but also needed to quickly understand changes and new actions required to ensure those are being built securely. With the status of the M&A activity, the container security agents were a non-starter. It was out of scope of what they could do as a security team. It was because Kubernetes is a complex, highly scalable solution developed to increase the speed and scale of deployment of applications, but not with security in mind. And because of this, there is a give and take that needs to happen to ensure that companies can quickly deploy without compromising their security. For both customers, agents weren't deployed across the entire environment. Working with companies scanning tens of thousands of cloud accounts, on average, we see that security agents are deployed on somewhere less than 50% of all cloud assets in cloud environments. That's not surprising if you think about it, because the agent has to be deployed, but also has to have the network connectivity set up to communicate back to the central tool. The agents need to be kept at the correct version that's up to date. They have to support the existing operating systems that you're using that may not be Windows or Red Hat that you used on-prem. But now it's Amazon operating systems, Linux, and maybe in containers, it's an Alpine or some other operating system that isn't supported by those agents. So you ultimately have to work with your DevOps teams to try and bake these into pipelines, which unfortunately become opt-in security. If the DevOps team does it correctly and the security team can audit it, maybe you'll get the agent deployed and maybe it will still be healthy. And it just gets worse as you deploy new applications and embrace new technologies that may or may not support agents at all. And then multiply that 10 times when you start acquiring new companies, because everything is so ephemeral inside those Kubernetes clusters, with the containers going up and coming down. Some of their legacy tools will report alerts and then go to the next day, which the security teams were spending cycles looking for, because it wasn't a Kubernetes-aware tool. It didn't understand that there are deployments that are going to spin these up and then tear them back down. One of the other things that we've seen through research is legacy security tools typically produce somewhere around 100 vulnerability alerts per asset. And now the number of assets has exploded. Instead of one VM with 100 vulnerabilities, you now have each container with a ton of vulnerabilities. Obviously, not all are critical, but it's a security team's burden to understand the result of the vulnerability scanner. dive deeper into it, and see what is critical. Then, even more importantly, understand who's responsible for solving it. With containers, it's not the owner of the VM who needs to resolve it. And it's not even the security team who needs to resolve it. It's whatever development team built it. And so having the metadata from the Kubernetes cluster is the only way to route that back to the actual owner. Trying to do that without a tool that is aware of Kubernetes clusters and the additional information is almost impossible. These two customers have looked to multiple best-of-breed tools that did not integrate or communicate. A network scanner, a vulnerability management tool, a CI/CD scanner, all these different tools feeling like they would make the job easier, but in reality, the security teams had to look at different systems and try to rationalize that together without a single pane of glass. It was burning hours just investigating things when a combined tool could link all of these together and use the context from the different tools to prioritize better. The phrase we kept hearing around the multiple security tools was the right hand doesn't know what the left hand is doing. Security tool A is saying this is a high risk. Security tool B is saying it's not exposed to the internet. Security tool C says there might be some PII involved. And without a unified tool, it was extremely difficult. So let's summarize this bit. We have agents that weren't deployed and poor prioritization. We have multiple tools giving multiple results across the same assets and cloud accounts. So it became clear that the numerous best-in-breed tools were not working for these organizations, which is why they came to Orca. This is where Orca's solution can help with this struggle. If you look at their core, these customers required visibility, context, and the need to consume the results about Kubernetes security posture. To meet these challenges, Orca offers an innovative way of scanning cloud accounts that requires no agents at all. Because Orca is built from the ground up to protect cloud accounts exclusively, Orca prioritizes the results with exposure or a blast radius that includes your crown jewels. The way that Orca can do this is through a technology that we've developed called side scanning. Side scanning is where we can use the existing cloud infrastructure and technologies to give a better level of protection that spans 100% of your environment. It is not security that relies on your ability to deploy agents, but rather it depends on the fact that the applications you are deploying and the clusters you are deploying run in the cloud account that you have protected. We protect that through the IAM role in that cloud account that allows us to take a snapshot of the running instance. Ultimately, the things that Kubernetes run are just containers on a VM that reside in your cloud account. Even if you're running a cloud-managed Kubernetes service like EKS, there's still EC2 instances under the hood. There's still VMs that we can take a snapshot of. And by taking those snapshots, we can reconstruct the virtual machine, we can rebuild the output of the operating system, the applications, and the data, and check for vulnerabilities or malware, insecure configurations, or exposed keys. We can also reconstruct the containers that are running. So we can see each container running in your containerization engine, if those containers have vulnerabilities, if those containers are running out of the base image, and more. Then Orca also calls the cloud metadata endpoints and the Kubernetes API. That way we collect the metadata around this container to understand the relationship between the container and the cloud infrastructure. We can see that the container is part of your internet-facing edge. It's part of the entities that attackers could potentially reach and exploit. Then we look in the opposite direction as well. What does it have access to downstream? What are the IAM roles and permissions associated with the container or with the underlying VM that it runs on? Then we can build this detailed map of the environment that goes wide because it sees 100% of your cloud across the different clouds and deep into the storage to tell you the operating systems, the vulnerability, and the malware that may exist on those nodes. So rather than just giving you a vulnerability and a VM name or the host name from the VM, you will get the information about the actual instance in the cloud account, its auto-scaling group, its launch configuration, and all that information. For the containers running in your Kubernetes clusters, you will get the additional metadata required to have an intelligent conversation with the development teams to tell them what they need to resolve. So rather than just saying this is the container name, you can say this is the image that it came from, this is the pod that it's running in, this is the deployment that you're running to have that daemon set deployed. And based on the tags at the Kubernetes level, I can tell you the owner, the maintainer, or whatever other tags your organization has put in. Also being able to look at things like your pod security policies and see the namespace. These capabilities will allow you to have intelligent conversations about Kubernetes with your developers to ensure they're resolving things the correct way. This goes beyond just vulnerability scanning. It ensures that your service configuration endpoints and deployment follow the best practices and the compliance frameworks you enforce in your organization. So what is the result of all this? We get all this information and then we can combine it into a map of the environment to give you the context and the prioritization needed to make sure you're resolving the most critical things first. Part of that is compliance as well. It is not enough to patch vulnerabilities or remove malware, but you also need to make sure that you're running your cluster in a compliant manner. In Orca, we can look at for frameworks like CIS benchmarks for EKS and run reports that give you trends over time, but go deeper as well to check if the actual underlying Docker daemon is configured correctly, or if the applications running in that container are configured correctly, and are the based images of the operating systems inside those containers. Once we have done all that, we end up with inventory information, topology, and compliance in your cloud, all agentless. Since we're combining the workload layer with vulnerabilities and malware and exposed key and all those alerts, we are combining the different layers with the cloud and Kubernetes control plane data. We can build that map and display that in your environment very, very quickly, only through creating an IAM role and permission. That usually takes about 5 minutes to onboard. You can reconstruct the entire cluster from the snapshot and the metadata to see exactly what is deployed and how it might be exposed to the internet. Then we can map the configuration of the clusters and the pods and the containers into all those different compliance frameworks without you needing to run a compliance agent or without you needing to settle for a tool that only looks at the cloud layer. And as a last step, we get the alerts with all the metadata. It makes it extremely easy to integrate your remediation steps as well. The metadata is what security teams require to be able to go back to the correct developer or the correct group or owner to get the changes done. It's not about patching the running asset, but about making sure you're committing that back to your source code, your repository, and your infrastructure as code. So to circle back to those customer stories, I want to talk a little bit about what those customers were able to get from Orca. Remember the rapid growth FinTech company? The multi-cloud deployment using infrastructure as code with a high turnover. The customer was evaluating multiple tools. Orca was one of them. They were most excited about the fast onboarding process. The fact that they could just onboard essentially all three clouds within about 5 minutes each, that's not an exaggeration. It's just running automation to create an IAM role, then linking it back to Orca. They gained complete visibility of their self-managed and cloud-managed Kubernetes clusters, even though they were using infrastructure as code for deployment and vetted the IAC files. There were inconsistencies in the configuration versus what was in those infrastructure as code files. There has been a drift configuration over time. Changes have been made to the running nodes that were not reflected in the infrastructure as code. This was the first time they had the visibility to see those changes, but more importantly, to see the potential risk introduced as part of those changes. So in this particular case, the result showed that 2 of the 3 cloud environments had overly permissive roles associated. One of those was configured with a secret store within the container images and with exposed keys inside the container images that had been baked in. So they have been deployed across the environment. Then all 3 of the cloud providers deviated from the compliance framework that the security team had agreed that they would all use. Because the team had the visibility needed, they could see the existing Kubernetes clusters and the ones going forward. So even if a new cluster was deployed next week or next month, they knew they would have the visibility on that. This let them identify new container vulnerabilities as they were deployed, and finally, it allowed the security team to implement proactive mitigation strategies to ensure that the workload protection was there without impacting the quality of life. So essentially, rather than bearing down on the DevOps team, the security team was hands-off as a light lift for the DevOps team with a ton of value for the security team. Our second customer, the multinational global media company, had grown through acquisition, and they had an environment that was a mixture of different types of Kubernetes. And they tried to move to cloud Kubernetes, so once Orca was onboarded, they could do a full risk assessment of their clusters and show how they compared back to those benchmarks they cared so much about. Orca was able to identify and highlight the risks in the cluster and also in the containers. Then the alerts were prioritized within the Orca dashboard to help them understand what they needed to tackle first. This was especially critical because many of their accounts were the first time they truly had any visibility into the deployed code. Now that the security team was happy with the results, they were most surprised, but they ended up working to resolve misconfigurations to the existing clusters before continuing the project of migrating more resources to the cloud-managed clusters. Using the data, the customer can now prioritize the migration based on risk and effort, so ensuring they gained visibility to the self-managed clusters and could see the highest risks first. To summarize, why did these customers choose Orca Security? What did they see in Orca that made this tool so valuable for them? It was the fact that Orca is agentless. So it avoids the agent deployment problem, agent upgrade problem, the agent connectivity problem, in favor of a modern next-generation cloud-focused tool. That meant not only did Orca understand the cloud better, but it was built more like the cloud and deployed like other solutions in the cloud. One of the teams said that we like working with Orca because this essentially scratches the agent deployment project off our books, since Orca has no agents. In addition, Orca can prioritize and monitor the alerts in our accounts based on cloud provider metadata and from Kubernetes control plane. It decreased the time to remediation, so the security team could quickly understand the risks and respond to the highest severity risks first. We've discussed Kubernetes and containers a lot. Orca does much more than this, but using those same techniques, the same way that we snapshot a Kubernetes cluster, we can snapshot a traditional VM or a ECS, whatever other thing you may have deployed in your environment. It's all done without agents. We don't run a single line of code in the customer's environment. Even though we report on all the alerts, we can prioritize those few alerts that matter. That 1% that have exposure to the internet or an attacker and have some lateral movement to or access. Even though we report on all of the alerts, we can prioritize those few alerts that matter. That 1% that has exposure to the internet or an attacker and have some lateral movement or access to sensitive data like your crown jewels in your environment. We correlate these together so you can see the attack paths that attackers would take from the public internet through your environment, through vulnerabilities, lateral movement, through misconfigurations into your crown jewels that span across VMs, containers, serverless functions. With the built-in compliance, we support over 60 different frameworks that span the different levels that we see. It is not just doing what a cloud security posture management tool would do. It is not just looking at the cloud APIs, but also the workloads, the operating systems, the applications, the Docker engine, and the Kubernetes clusters to make sure that those are running in a compliant manner. And finally, automation and customizations are essential. We have a very mature and robust set of automations, an automation engine that goes into a set of integration tools. So all of the tools you might be using today to alert your team, sending via Slack or Teams, sending PagerDuty alerts, triggering workflows in your SOAR tools, or even forwarding onto Splunk or Sumo Logic or Datadog, etc. We support all of them. Orca provides a holistic look across the environment to ensure that different threats are considered comprehensively, to provide context for the alerts given, which are displayed in a consumable way to ensure that the teams can understand them. We have a free risk assessment. You can scan the QR code right here. You'll get a link on how you can onboard at no risk, no obligation. You can connect your cloud accounts within 24 hours. You'll have complete visibility into your cloud infrastructure. You'll get a one-on-one with a cloud security expert like myself to look at your results, understand the critical risks in the findings, and get a report. We're confident that the visibility and the data that we give will far exceed anything you've seen into your cloud accounts at this point. Thank you for your time.